So, in the previous lecture, we have seen the key technologies which are the hearts of the IoT or IIoT, which is basically sensing and actuation. So, sensing and actuation are very important, but then what these sensors and actuators can do? The sensors basically can sense some physical changes in the characteristics of the environment in which it is operating. So, let us say the temperature sensor, the example that I was giving you earlier. So, this temperature sensor can sense the changes in the temperature characteristics of the environment in which it has been deployed, in which it is operating. But then once it has sensed, so it produces some signal, but then that signal will have to be sent somewhere, without which that signal, the changes that have been detected are not useful. So, how do you send it? So, for that particular purpose, basically you need to take help of different communication protocols that are there, the communication systems and so on. So, connectivity is the bottom line. So, we need to understand what is this connectivity issue and what are the different available connectivity technologies, and we will talk about it in the context of IoT in general, and this also applies to IIoT, but then for IIoT we will talk about these things in further more detail in the lectures to come. So, let us look at some of the basic issues of connectivity in this lecture as well as the next one. So, these are some of the communication protocols that are typically used for IoT. So, the first one is the standard, the IEEE 802.15.4 standard. Then you have different other protocols such as the connectivity technologies such as the Zigbee, 6LoWPAN, WirelessHART, Z-Wave, ISA100, Bluetooth, NFC, RFID and so on. So, some of these we are going to go through in this lecture and the next. So, let us start with the 802.15.4 IEEE standard, which is used heavily for connectivity purposes in IoT. So, basically this particular standard, as you will see in the future, is something that is used heavily in order to help the sensed data to be sent over a network to some remote device for further processing, and based on that processing again that signal has to be sent from that processor to some remote actuator which will do some actuation, and that actuation could be turning on the lights of a room. So, we are talking about what we are talking about. Let us say that we have these sensors, this is the sensor. Let us say that we have the actuators over here, we have the actuators, and in between we are talking about that the sensed data will have to be sent to some storage or some processor, right. So, let us say a laptop or something, a processor or whatever. So, this has to be done, and after that based on the processing this data again some signal might be required to be sent to the actuator, right. So, what is required is to understand this part and this part, how you are going to use, how you are going to send that data, which technologies you are going to use, which standards you are going to use, and then the corresponding protocols that will be used. So, we are talking about the different protocols that will be used over here, and IEEE 802.15.4 is one such very widely used standard for offering connectivity in IoT. So, let us try to understand 802.15.4. So, this IEEE standard basically provides a framework that is meant to be used particularly for networks such as the wireless personal area networks. Personal area networks means like these operate in a very small scale, right, small scale, the range is very small and so on. So, this personal area network, the wireless personal area network, the layers such as the physical layer and the MAC layer. 802.15.4 basically talks about the definition of how these physical and the MAC layers are going to be used. So, physical layer, just to give you a little bit of brief about what this physical layer does in case you do not already know. The physical layer basically defines things like the frequency band in which the communication is going to happen, the transmission power, modulation scheme that is going to be used and so on. So, these things are defined by the physical layer. The MAC layer on the other hand talks about things like different devices trying to get access to the medium for communication, which protocol is going to be used, how they are going to send, when they are going to send, what is the discipline that is going to be followed and so on. And then the frames that are there, which are basically the PDUs in the data link layer, these frames, how they are going to be sent, how the flow control, the flows of the frames are going to be maintained and so on. So, this 802.15.4 standard is typically meant for use in communication where there is low power, low cost, low speed requirements that are there. And this communication will have to happen between devices which are separated by typically less than 75 meters, 10 to 75 meters and so on typically, but different operating conditions will result in different ranges and so on. So, in terms of the coding scheme that is used is a scheme which is known as the DSSS, the direct sequence spread spectrum coding scheme, that is used to transmit information. So, this this is a big story, just in short, this is kind of a coding scheme which will encode the data and it will be sent. So, the reason this DSSS is used is that it offers increased security, reliability and so on, and this is quite widely used, reliability because these systems basically these IoT systems typically operate in noisy environments, interference where there is a lot of interference and so on. So, DSSS kind of encoding scheme is good for sending information in these kind of channels exhibiting these noisy characteristics. So, this DSSS uses phase shift keying modulation. All of these things, if you do not already know, it will be a little difficult for you to know, but just briefly let me tell you that it uses the phase shift keying, something known as the modulation scheme is known as the PSK modulation, phase shift keying modulation, to encode the information. The information will have to be encoded using PSK and the different variants of it. So, the first one is basically the BPSK modulation, BPSK, binary phase shift keying, and this is typically used for requirements of data transmission rate of about 20 to 40 kbps and in this particular frequency band 868 915 megahertz frequency band. And there is another one which is used for the 2.4 gigahertz frequency band, which is the OQPSK, which is basically the offset QPSK, quadrature phase shift keying, and this offers a higher data transmission rate of about 250 kbps. So, this BPSK offers 20 to 40 kbps, right, and this one offers about 250 kbps, a higher data rate in the 2.4 gigahertz frequency band. So, so as I was telling you earlier that DSSS is good because we are talking about IoT environments full of noise, interference between different devices, and DSSS is a standard that will be highly tolerant to these kind of unwanted characteristics, unwanted things like noise and interference. And so, what is happening? So, ultimately you are talking about offering link reliability, right. So, that link reliability means that you have to ensure that whatever you are sending reliably reaches the destination. So, that is why this DSSS is good in order to achieve these kind of characteristics. So, these are some of the features of 802.15.4, that it operates in the line of sight and that is the preferred nature of transmission. The range typically is about 10 to 75 meters, and which I was telling you earlier. The MAC protocol that is typically used is the CSMA-CA protocol, carrier sends multiple access with collision avoidance, and 802.15.4 has a requirement because it has to work in systems which have low power, which are powered with very small batteries, low power requirements are there. So, it basically is used in transmission systems where there is a requirement of producing or using low duty cycle. That means the sensor will be active for a short duration of time, because that will reduce the power consumption. So, in this kind of environment 802.15.4 is useful. And the topologies that are typically used are network topologies such as the peer to peer topology, the star topology, and so on. So, there are different variants of 802.15.4 IEEE standard. The basic version is the 2003 version, where the modulation scheme and data rates were fixed for different frequency bands as 868, 915 megahertz and 2.4 gigahertz. In 2006, the next variant came, which is basically popularly known as the 802.15.4b, which is about offering or trying to offer higher data rates compared to the previous version that was available. So, higher data rate. Then we have what? We have the next one, which is basically 802.15.4a, which talks about increasing the range capability. So, then came the 15.4c, which talks about using the 780 megahertz band in China for offering connectivity and communication. So, this basically uses OQPSK or MPSK, multiple phase frequency shift keying mechanisms for data transmission over rates such as 250 kbps and so on. Then you have the D variant, which basically provides 980 megahertz band communication in Japan, and here it uses the GFSK and BPSK with different data rates. The E variant, which basically is particularly meant for serving MAC applications for industrial environments. F variant is for particular use in RFID applications. G variant for smart energy, smart grid, etc., those kind of environments. So, these are the different variants of 802.15.4. So, this particular standard is a standard that is widely used. 802.15.4 is widely used in IoT applications. Now, there are different protocols like the Zigbee protocol, which is primarily based on 802.15.4. So, this Zigbee protocol provides a framework for medium range communication to offer IoT connectivity. It defines the physical layer and MAC layer characteristics, enabling interoperability between multiple devices at low data rates. So, Zigbee basically offers low data rate, medium range communication capabilities between IoT devices by making certain changes or defining certain characteristics in the physical layer and the MAC layer. So, Zigbee operates in 3 frequencies: 868 megahertz, 902 to 928 megahertz and 2.4 gigahertz, and each of their channel characteristics and the data transmission rates are as shown. So, the lower frequency bands in Zigbee use BPSK, the 2.4 gigahertz band uses OQPSK, the offset QPSK, and then the data transfer basically takes place in 128 bytes packet size. So, each of these packet size in Zigbee is typically 128 bytes, and the maximum allowed payload is 104 bytes, and the nature of transmission is typically not necessarily line of sight, and if you have line of sight, then you will get better data rates using Zigbee. And to some extent non line of sight also sometimes will work with reduced data rate, reduced range and so on. And the standard range of transmission is about 10 to 70 meters in Zigbee. So, Zigbee basically helps in packet transmission. Packet transmission over greater distances with the help of the concept of relaying. Relaying means what? It is about that if there is one Zigbee device which receives a packet, then it is going to send to one of its neighbors, and through some multi-hop process communication, the data from the source will be received at the destination node. So, this basically Zigbee basically supports this relaying concept, this multi-hop communication concept, because of which the communication range basically virtually can be increased. So, it provides low power communication around 1 megawatt per Zigbee module, and it has different features such as offering adaptable duty cycle, low data rates of about 20 to 250 kbps, low coverage ratio of 10 to 100 meter and so on. And Zigbee supports different network topologies such as the star topology, P2P, cluster tree topology and mesh topology, and the mesh is the one of the most widely used topologies using Zigbee. So, the Zigbee protocol defines three types of nodes: the coordinator node, the router node and the end devices. The coordinator, as this name suggests, takes care of issues of initialization, maintaining and controlling of the network, and there is normally one and only one controller per network. Then you have the routers, which are typically used for multi-hop kind of routing. They help in the multi-hop routing, transmitting the data packets that are received even further. And then you have the end devices, which basically are the recipients of the data. They do not contribute to further routing. The topology that is used are star topology, and in the star topology there is no router, one coordinator and 0 or more end devices. If the mesh and the tree topologies are used, there is one coordinator that maintains several routers and end devices. So, each cluster in a cluster tree network topology, if the cluster tree topology is used, involves a coordinator through several leaf nodes. So, there is some cluster and then there is a tree kind of structure, and so you have the cluster tree kind of topology, and the coordinators are linked to the parent coordinator that initiates the entire network. So, Zigbee standard comes in two variants. One is the regular Zigbee, the normal Zigbee, and then there is the Pro variant, Zigbee Pro, which basically is attractive because it offers issues of scalability. That means you will have better range. Zigbee Pro will give you better range, scalability can be improved of the system, can be improved. Security, Zigbee Pro offers better security, improved performance, utilizing many to one routing scheme and so on. So, these are some of these different types of variants of Zigbee devices, Zigbee modules that can be there. So, before I go to the next topic, I also wanted to talk about something. So, let us talk about this Zigbee protocol that I mentioned. So, in Zigbee I said that you have the physical, then you have the MAC, right, and you also have different layers such as the SSCS, then you have the LLC, and then you have the network layer. So, these are the different layers as you can think of. These are kind of sub layers, and this MAC can talk to this one and like this, okay, and this is also possible. So, this is how this Zigbee stack looks like. Now, if you want to map it to your traditional OSI, which is used for the internet, you have the physical layer, you have the data link layer, you have all these layers all the way up to application, right. So, this basically this Zigbee MAC and this one will typically, and here you have the network layer. So, this can work in this range. Okay. This is how this mapping between the Zigbee and the OSI looks like. Okay. Now, let us go back and we look at the next protocol, which is the 6LoWPAN protocol. So, this 6LoWPAN, you must be wondering that what is this 6 all about. You may not have heard of any protocol that starts with a with a numeric value, the name of a protocol starting with a numeric value. So, this basically this 6 stands for the letter 6 in IPv6. So, 6LoWPAN is about use of IPv6 over wireless personal area networks like the ones that we talked about earlier in this lecture, local local personal area network, not local area network, but the personal area network, the wireless one, and where there is low power wireless personal area networks, IPv6 over that is what is enabled using 6LoWPAN. So, it optimizes 6LoWPAN optimizes IPv6 packet transmission in low power lossy networks such as the ones that are supported by the standard, the IEEE 802.15.4 standard. 6LoWPAN operates at two frequencies. One is the 2400 to 2483.5 megahertz frequency band, which is used worldwide, and the other one is in North America, which is the 902 to 929 megahertz band. So, it uses 802.15.4 standard in the unslotted CSMA-CA MAC protocol mode. So, this is a MAC protocol, unslotted CSMA-CA MAC protocol. So, there are some features of 6LoWPAN. I am just going to enumerate, I am just going to mention a list of such features. So, 6LoWPAN basically converts the data format to be fit within 802.15.4 lower layer system. IPv6 basically involves MTU of 1280 bytes in length, while 802.15.4 can permit a packet size of up to 127 bytes. So, now you see that there is a big mismatch, 1280 is permitted by IPv6 and 802.15.4 allowing 127 bytes only. So, this can be achieved with the help of a layer which is known as the adaptation layer, which is introduced in between the MAC and the network layer, and that can help in packet fragmentation. Fragmentation has to be done because 1280 and 127 there is a mismatch in the sizes. So, fragmentation has to be done on one end, and then reassembly of these fragments will have to be done at the other end. So, this adaptation layer will help you with both, and it also does few other things such as the compression of header, routing of data link layer and so on. So, routing basically this routing help with the routing is also performed on top of the data link layer with the help of this particular adaptation layer. So, fragmentation. So, fragmentation is required, as I said, in order to be able to fit the intact IPv6 packet into the IEEE 802.15.4 frame. So, this fragmentation header allows 2048 bytes packet size with fragmentation. Using fragmentation and reassembly, 128 byte IPv6 frames are transmitted over 802.15.4 radio channel into several smaller fragments, and this is what I told you just a while back. So, this fragmentation will help you to do it, but then after fragmentation again at the other side you will have to do the reassembly. So, this IPv6 will take care of not IPv6, the 6LoWPAN protocol, the adaptation layer will basically take care of both the fragmentation as well as the reassembly. So, as I was telling you, there has to be some kind of header compression that has to be done, and this header compression basically reduces the transmission overhead and allows efficient transmission of payload. So, IPv6 addresses are compressed in 6LoWPAN into two types. So, as 8 byte UDP header and 40 byte IPv6 header. So, 6LoWPAN does not use, it is not based on top of DHCP. Here basically it is stateless, unlike DHCP. Here basically what is used is something similar to SLAAC, which is for stateless auto configuration. So, this stateless auto configuration or SLAAC protocol is used in contrary to DHCP. DHCP is not used in 6LoWPAN. So, so in data link layer, routing is classified into two schemes. One is the mesh under, which utilizes the link layer addresses to provide to forward data packets, and the other one is the route over, So, route over basically utilizes network layer IP address. Okay. So, mesh under and route over are two different schemes that are used in the data link layer for 6LoWPAN. So, let us look at, and one more thing is that this AES 128 link layer security is used. So, now let us look at one aspect, which is basically how this mesh under and the route over, these schemes are used. So, in both you have what? You have the physical layer, then you have the MAC layer, then you have this adaptation layer, which is the 6LoWPAN adaptation layer, then you have the network layer, then you have the transport layer, and then you have the application layer, and this side also the same thing, physical, MAC, then this adaptation layer, network layer, transport layer, and application layer. So, this is application, by the way, this is adaptation, this is application, right. So, the difference over here is that in the case of mesh under, this routing is done in the adaptation layer. So, routing basically is done in the adaptation layer, whereas in route over, this routing is done as traditionally in the network layer. So, this is the main difference between this mesh under operation and the route over operation, where this routing is done, in one case in the adaptation layer, in the other case in the network layer. So, now let us come to another protocol, which is the wireless HART protocol. So, this wireless HART protocol is used particularly for industrial applications. The full form of HART is Highway Addressable Remote Transducer, and it is based on 802.15.4 standard IEEE once again. It functions in the 2.4 gigahertz ISM band using data rates of up to about 250 kbps, and there are 11 to 26 channels that are supported with a spacing of about 5 megahertz between two adjacent channels. And it is also this wireless HART protocol also makes it mandatory that the same channel can't be used consecutively. So, this channel spacing is very important in the wireless HART protocol. So, the features of some of these features of wireless HART is that it uses again DSSS based on 802.15.4 DSSS coding scheme, which I told you earlier, and then this wireless HART protocol, the node that is used which follows the wireless HART follows the channel hopping every time it sends a packet, and the modulation scheme that is used is the OQPSK, offset, quadrature, phase shift keying, and the transmission power is around 10 dBm. So, these are some of these different features. There are other features such as the payload size that is allowed is 127 bytes. The MAC protocol that is used is TDMA, and this TDMA technology is used to provide collision free and deterministic communication, because there are different time slots in which the communication takes place between these different nodes. So, there is no collision, and a sequence of 100 consecutive time slots per second is grouped into something known as the super frame, and this super frame concept is very important, and we will talk about it little bit more in detail. So, a super frame is basically nothing but 100 consecutive time slots per second grouping that is done. Okay. Now, let us look at. So, the devices that support these multiple super frames will have differing number of time slots, and at least one super frame is always enabled, while additional super frames are enabled and disabled according to the demand of the bandwidth. For any message, the communication occurs in the allotted time slot and the frequency channel, and this supports both the star and mesh topology. So, wireless HART basically supports both star and mesh topologies. So, these are some of these features of the wireless HART, and as we have seen, industrial applications are the ones where wireless HART has been found to be very attractive for use. It is based on the 802.15.4 standard, like the ones that we have discussed before, like Zigbee and so on, and it is a very attractive protocol for industrial applications. If you want to know further about wireless HART and the other protocols and the standard 802.15.4 in more detail, these are some of the references that have been given to you. This lecture introduces you to only these protocols. It only introduces you, but then if you need to this kind of understanding will be sufficient for you to go ahead with the further lectures that we have in this course. But in case you need to go ahead, these are some of these references that are listed on the slide, which you can go through in further detail and gain even more in depth in understanding if you require to. So, with this we come to an end. Thank you.